Alright, you guys. So for the fifth day, this was a really interesting problem. So basically, the elves have cleaned up the camp, and now it's time to unload the cargo from the ships. So doing it by hand would be pretty difficult because I guess the cargo is very heavy. On one of the ships, they have a giant cargo crane, and they can use it to move the cargo around. How this crane works is that it takes as input a list of moves. They will give it like I guess like an old computer with paper input, and this crane will just move the crates from the ships onto the camp. And so I guess our job is to simulate how the sequence of moves that the elves prepared will work, and to validate that it works we have to provide them the crate identifiers that will be on the top of each stack. So our input will be the initial stacks from the ships and the camp, and after that we'll receive the moves, and each command will contain the number of crates that we want to move, the index of the first stack, of the source stack, and the index of the destination stack. From the instruction manual, the crane operates by taking crates one at a time and moving them from the source stack to destination stack. So they will be in reverse order when they will be moved. So in the example we have three stacks. The first stack will have the Z crate on the bottom and the N crate on the top. The second stack will have the M, C, and D crate from bottom to top, and the third stack will have the P crate. So first we have to move one crate from the second stack to the first stack. So we'll take D and put it on top of N. After that we have to move three crates from the first stack to the third stack. So we'll move first we move the D crate, then N, and then Z. Then we have to move two crates from the second stack to the first stack, so we move the C first and then M. And finally we have to move one crate from the first stack to the second stack, so we move the M back to the second stack. And to validate our answer we have to check with the elves if C, M, and Z are the top crates for each stack. So we have to do the same thing but for our input. Then for the second part of the problem, which in my opinion made it easier, I don't know, but first I implemented the second part. Crate mover actually is able to pick up more than only one crate. So instead of moving them one by one, it can pick up three at once and just move them in the same order. In the previous example, when we have to move three crates from 1 to 3, instead of moving them D, N, and Z, we just move them in the same order. And in the third stack it will be P, Z, N, and D at the top. When we move a single crate, it will work the same as before. But for example, when we have to move three crates from the first stack to the third stack, they will remain in the same order. So we move Z, N, and D in the same order. Then when we move two stacks from the second stack to the first stack, they will again be moved in the same order. And finally we just move a single crate from the first stack to the second stack, but this time the output will be MCD. So for this problem the biggest challenge I guess was parsing the initial stacks. So to organize the code a bit I created the structure for the move operation, and it will have a count field to represent how many crates we move, the from index of the stack and the to index of the stack. Then to parse a single move I implemented the from stir rate, and so I guess here you can use regex, or I'm not sure, but I think the easiest way is to just split by spaces and then take the items that represent the numbers. So for the commands it would be the second item, the fourth, and the sixth items that you need to take, just convert them to numbers. So I subtracted one from the source and destination fields because in the problem statement they use one indexed arrays, but I guess we use zero based indexing, so it would be easier to just have them zero based. Then to parse the stacks, my idea was to read the string that represents the first part of the input, the first half, and then transpose the input so that instead of having to parse vertical stacks, we just parse horizontal stacks, which is easier. So I implemented this transpose function that takes as input a matrix. It will be a vec of T. I guess I made it generic just because I thought it was more interesting than just using a character. So I guess this is some basic functional programming stuff, but I don't know, it was really difficult to do it in Rust because the compiler was complaining a lot, and I finally managed to do it using a fold. The idea is to split the initial matrix into the first column and a list of the other columns. Then you apply transpose on the tail of the matrix, let's say on the rest of it. And after you transpose the tail of the matrix, you just insert as a line the head. So at the end, it will be each column will become a line in the new matrix. So I split the matrix. So I split the matrix into two by using a fold. So the accumulator will be two vectors, an accumulator for the head and an accumulator for the tail. The line will be the line from the input. And here what I did was to split on the first index. So here H will be a slice that will contain the first character in the list, and T will be the tail of that list. Then we just add the first character to the head accumulator, and we add the tail of the line to the tail accumulator, and I guess we return the accumulators for the next step. So basically after this stage we'll have a vec of characters for the head and a matrix of characters, like a 2D array of characters without the first column. And if we apply the transpose function on the new matrix, recursively we'll get the transposed matrix at the end, and then we have to insert the first column as a line. So basically, to parse the stacks, we read the lines and convert them into a 2D array of characters. Then we transpose the input, and then we'll have a lot of lines that are just blanks or brackets, and we have to skip them, and we only have to keep the lines that contain the crate identifiers. So the first line we skip, and then we have to step by 4 to get only the important lines in the input. And we also skip the last item in each stack because that's the identifier of the stack, and we don't really need it because we parse them in order and the stacks are also in order in the input. Oh yeah, and we also remove all the spaces because to fill the stacks to up to the top, they use white spaces to make the input like a square. Also, to parse the input, I split it by two new lines and just got the stacks input and the moves input, and after that I returned the tuple where I used the parse stacks function that I made, and then I used the from stir trait to parse the moves. Then to solve the actual problem, I implemented two functions for each part, one act 9000 for the first part, and the funny thing is that I actually implemented the second part first, but after I failed once, I realized that I have to use reverse for the first part. So how it works is that this function takes as input the stacks. It removes the first count items from the from stack. Then it reverses the removed items and it appends them. I guess it inserts them in the beginning of the to stack, and then it returns the modified stacks. For the second part, you just have to remove the items and add them back in the to stack. You don't have to reverse it. And for the solution, I just applied the act functions for each move. So basically I simulated how the crane would work. And after you go through all the moves, you go through each stack and take the first character from each stack and convert it to a string. And that should be the answer. So yeah, this was the fifth day. I guess implementing the solution was really easy. The only difficult part was to parse the input. But yeah, I always think that's fun to do, to create a parser that works on all the inputs, because yeah, I guess you could have just copied the stacks from the input file and only parse the moves, but I guess you can do that just to prove that your algorithm works, and if you still have some time after that, you can create a parser for the input. But if you want to check out the code, you can find it in the description, and yeah, I guess I'll see you guys next time. Bye.